Lesson 5.6. Our outcome is going to be to find the domain and range of a linear function. We're going to define a piecewise function, and we're going to write the equation of a piecewise function. So first things first, we want to look at linear equations. We've been doing linear equations since school started. The linear graph shown is a model of a skier's elevation over time while skiing downhill. So just look at the graph for a minute, pause it and take it in. What's it talking about? We have our time down here, we have our elevation over here, and we want to find the constant rate of change at which this skier is going down the hill. So I want you to take a moment, pause it, and find the slope. Find the slope of this line because we're going to write the equation for it. That's behind this blue box right here. Okay? Remember, to find slope, it's y2 minus y1 over x2 minus x1. So you're going to need two ordered pairs. Okay? You can get one of those right here. That's a perfect spot where it intersects. And there's also an ordered pair right here. So go ahead and pause it for a moment and find the slope of this line. Here's the slope. The slope is -5, which means that I'm going every 5 feet I go down, it takes me 1 second. So every 1 second that I travel, I'm going down the hill 5 feet. Okay, so we found the slope. You know how to find the y-intercept. Look at this. Where does this graph hit the y-axis? This one's pretty easy because it hits it perfectly. You don't have to plug it into y equals mx plus b. Okay, where does it hit? It hits at 320. So our b is 320. That's our y-intercept. It's where we start. So put it together and write the equation. Go ahead and do that. Alright, here's the full equation for that linear function. This is a linear function. This we know how to do. Okay? It's writing the equation for a line. Okay, so this is a linear function. Regular old equation like we've been doing the whole time. Straight. A piecewise function is not straight. So that's where we're going to go to next. So here we go. The diagram shown provided illustrates a trail that they will be hiking. The diagrams are not drawn to scale. I drew this example because I want you to look at these two. Okay? So based on the aerial view, is this a linear function? Yeah, it forms a straight line. So this one here is a linear function. Straight line, not a big deal. Here though, when you look at it at the side of this trail, so you're standing on the side of the mountain and you look at it, look, it changes rates of change. There is no constant rate of change for the whole thing. There's a constant rate of change right here, and there's a constant rate of change right here, but not from the campsite to the picnic area. And that's what we call a piecewise function. Okay? So this section has an equation, but this section will have a different equation. Whereas this linear function right here has the same equation the whole way through. So piecewise functions, now you don't have to write just one equation, you're going to have to write 2 or 3. And that's what we're going to do here. So here we go. Here's just an example, time and distance, and every one of these little dots is going to be worth 1 point. Okay? So I want you to first just determine, is this a piecewise function or a linear function? It's a piecewise function because each section is different. From here to here, that's one section, so we can call that A. Here's another section. It's different. We can call that B. And then this section is different. It's going to have its own section, and we can call that C. Okay? So yes, this is a piecewise function. Now I have the words domain and range down here, and that's what we're going to do next. We're going to find the domain and range for each one of these sections. So here we go. Here's the same exact piecewise function, and we're going to label them. I called them A, B, and C before. We'll just call them piece 1, piece 2, and piece 3. It really doesn't matter what you call it, okay? So, for piece 1, domain, that is all my X values. Good. So you got to look. Pause it and find out what is my domain of just this section, okay? I start at 0 and I go to what? I go to 2. Very good. Okay? Go through and find the domain for piece 2 and piece 3. Pause it right now and do that, please. Piece 2. The domain is 2 to 7. So on my x-axis, I go from 2 to 7. So 3, 4, 5, 6, and 7. Those are all included, okay? And as you'll see for piece 3, I wrote them all out, okay? I don't know if you can see that one. Piece 3. We go from 7 all the way to 13. So 7, 8, 9, 10, 11, 12, and 13. Those are all of my domain values. So you can write it one of two ways. You can either use the word 2 or you can put them all out there. Alright? So if domain is the x value, then range has to be our y values. So take a moment and look. Where on the y-axis does piece 1 fall? It falls from 0 all the way up to 1, 2, 3, 4. So it should be 0 to 4. And there it is. Pause it now, and you find the ranges for piece 2 and piece 3. Piece 2 is special because it's just 4. It doesn't go any higher than 4. So the only range value is 4. And then for piece 3, our range values, well, it starts 1, 2, 3, 4. Well, let's see. 1, 2, 3, 4. There we go. 4, and it goes all the way to 0. But you write it the way that you read, and we start with the smallest number first. So again, it would be 0 to 4. Okay? Those are our range values. All right. We have domain and range under control. Now we need to write the equation. Ooh, hold on one second. Let's get a little shade here. There we go. Okay. We got to take this an equation at a time, okay? I first want to focus on the red. Write the equation for this line. The first thing you have to find is slope. What is the slope of this line? Now, each one of these is worth 1. So you could do ordered pairs, and you could do y2 minus y1 over x2 minus x1. But I say let's not do that. This is real easy. Count the dots. What's my rise? 1, 2, 3, 4. What's my run? 1, 2. So I would have 4 over 2 for this one. And I feel like 4 over 2 simplifies. What does it simplify to? It simplifies to 2. So my slope for this first one is 2. What's my y-intercept? Where does this piece hit the y-axis? Right here at 0. Now notice I did this one in red. So here's my first equation. Look at that. 2 over 1x plus 0. Now, you're algebra students, so we need to start getting rid of the plus 0, and we need to get rid of this. It simply needs to be 2x. That's the equation for this piece of the line. All right, we're not done. We got to do the blue section. So here we go. This section, what's the slope of that line? Calculate it. Do y2 minus y1 over x2 minus x1. Does it have a slope? No. This is one of our special cases. Do you remember the name? Zero slope. This has zero slope. Okay? However, what is our y-intercept? This line will always be at y equals 1, 2, 3, 4. Count the dots. Let me erase this here so you can see. Okay? Look at that. 1, 2, 3, 4. And that runs right into this line. So if I had y equals 4, that would be this line right here, that straight section. Okay? So I'm going to pull this down. There it is. Y is equal to 4. Now, we're going back to our f of x. Just remember that that's y. Okay? So the function of x is 2x. There's the first equation. There's the second equation. We got one more. Let's do the yellow part. Here we go. Find the slope. Is this going to be a positive slope or a negative slope? It's going to be a negative slope. Let me move this out of the way so you can count. Okay, let's count it. 1, let me get my pen. Hold on. Here we go. 1, 2, 3, 4. So down 4. And what's my run? 1, 2, 3, 4, 5, 6. Okay, which one goes on top? The rise or the run? Good. The rise. So negative 4 over 6, simplify that. Negative 2 over 3. The slope of this line is negative 2 over 3. Now for this section, let's put that yellow back on there. Do we know the y-intercept? Do we know where this line would continue and hit the y-axis? No. So all you can do is find the slope. That's it. You can't find the y-intercept for that one. And that's where we have this right here. Okay? Let me see if you can see that. Alright, let's zoom in on that. Okay, I know it's in yellow. Okay? Negative 2/3. Okay? So this piecewise function had how many equations? 3. It had 3 equations because there are 3 pieces. Alright, last one. Here we go. How many pieces are there? There's 3. There's 3 different pieces in this piecewise function. So, start with the equations. Pause it for a minute. I want you to do this on your own. I want you to find the slope and the y-intercept for each one of these. The slope for this one is 1/4. I rise 1, I go 1, 2, 3, 4, and I hit the point. My y-intercept is just 0. So as an algebra student, do I need to put plus 0? No. So there's my first equation. Second equation. Again, please stop the video and find the slope. You do it. It does you no good just to listen to me tell you the answer. Alright. Slope. This one's 4/1. We have to go up 1, 2, 3, 4 over 1. So there's my second equation. Let's put them like this. Alright, last one. This one has no slope. It has 0 slope. But it has a y-intercept at 6. You would have had to count the dots. 1, 2, 3, 4, 5, 6. And that's it. Those are my 3 equations for this one. Oops, let me get rid of this. There. For this one piecewise function. There's 3 pieces, thus we have 3 equations.